Welcome to this video on mastering bitwise operations. We'll visualize AND, OR, XOR, NOT, and shifts at the machine level to understand how they manipulate data. Bitwise operations bypass high-level math to manipulate data at its most fundamental level, the individual bit. This low-level processing is foundational to systems programming, cryptography, and optimization. Machine memory remains constant whether represented in base 10, base 16, or base 2. Bitwise operations require seamlessly shifting between these different numerical formats to access the absolute truth of base 2. Bitwise AND, the gatekeeper, returns 1 only when both input bits are 1. Its key uses include masking specific bits and checking if a bit is set. Bitwise OR, the combiner, returns 1 when at least one input bit is 1. It is useful for setting specific bits to true and combining configuration flags. Bitwise XOR, the switch, returns 1 only when the bits are different. It is commonly used for toggling bits on and off and natively swapping values. The bitwise NOT operation, the inverter, completely inverts every bit. A key warning is that the final numerical result heavily depends on the defined bit width of the system. Bit shift operations physically move all bits in a register left or right. They provide a highly optimized way to multiply or divide by powers of 2, acting like a conveyor belt for the bits. This master matrix summarizes the core bitwise operators: AND for masking, OR for combining, XOR for toggling, NOT for inverting, and shifts for multiplying or dividing. In the permission stack architecture, OR is used to build a single-state integer combining flags, and is then used to check or extract specific permissions without altering the overall state. Bitwise XOR acts as a perfect mathematical toggle switch for feature flags. Applying the exact same mask can turn a bit on if it's off, and off if it's on. To isolate specific data segments, like extracting the lower 4 bits or a nibble, developers use a hexadecimal mask paired with the AND operator. This strips away unwanted data efficiently. The power of bitwise operations lies in state density. They allow packing complex configuration state into microscopic memory footprints, evaluating it in a single CPU clock cycle, compared to multiple bytes and cycles for Boolean flags. The MiniWebTool Bitwise Calculator is the ultimate developer workspace. It translates abstract operations into step-by-step logic diagrams and seamlessly handles decimal, binary, and hexadecimal inputs. Elevate your workflow by using the MiniWebTool Bitwise Calculator to verify logic, optimize code, and visualize binary arithmetic instantly. Access the free format-agnostic tool online or upgrade to premium for an accelerated engineering toolkit.